So welcome, everyone. My name is Sean Finn. I'm with the U.S. Fish and Wildlife Services Science Applications Program in our Mountain Prairie region. Today, we will be presenting Virtual Classroom 3, an introduction to climate tools. And we have 4 speakers that will talk about climate decision support tools and why and how to use them. I think you'll find the hour quite engaging, hour and a half here. I just want to remind folks that this virtual classroom is part of a larger climate change and climate adaptation training for sagebrush conservation practitioners. There is a website that you can see that is now in the chat box that I hope you will visit. You will see this is the 3rd of 4 virtual classrooms. The 4th one that we present will be next week. And the subject of that virtual classroom or webinar will be interpreting climate models. That will be followed later in the month of May by an in-person 2-day completely free workshop on climate change and sagebrush ecosystems to be held in Boise, Idaho. Information on that workshop and the ability to register for it for free are also available on the website that you see in the chat box. Today, we're going to have, as I said, 4 folks that present on climate tools and how to use climate tools. And we're going to start with Dr. Steph McAfee. Steph is the USGS Regional Administrator for the Southwest Climate Adaptation Science Center. She formerly served as the Nevada State Climatologist and an Associate Professor at the University of Nevada, Reno. So please mute yourself, everyone except Steph, and Steph, take it away.
Hi, everyone. Sorry, it just always takes a minute to get going here. So I'm going to provide a brief overview of how and when you might use climate adaptation tools. But before we get started, I want to acknowledge that you all also already have difficult, challenging jobs. When we're thinking about managing sagebrush ecosystems, we're thinking about a wide variety of ecosystem characteristics, an array of uses, competing priorities, and of course, the emergencies that we expect, dealing with flood, fire, and drought. On top of that, people are now being asked to consider climate change. And there's just an explosion of climate tools. In just a couple of minutes online, I was able to go and grab a number of these different tools that pop up. So today, we really have 2 main goals for you. One is to feel more comfortable navigating that landscape of tools and figuring out which ones are going to work for you. And then we're going to explore 3 particularly useful tools. So Catherine will be demoing the Climate Toolbox, which is used to visualize current and future climate. Michelle will be showing you the Land Treatment Exploration Tool. And then finally, Bryce will demonstrate the Climate Smart Restoration Tool. And all of these have different places in the climate adaptation landscape. So one question you might have is, what should I be looking for in a tool or a data set that I'm going to use? Well, one of the obvious things you should look for is that it has the data you need. Here I have an image from the Climate Mapper, which is part of the Climate Toolbox. Again, a wonderful tool, but it, like many tools, limits a lot of data sets to CONUS. So if you're working with partners across the Canadian border, this particular data set here in this mapping tool might not be the ideal product for you. It also has you also want to look for a tool that has the variables you need. So in this case, I'm showing you the Climate Explorer. This is a NOAA product. Again, a very reliable product put out as part of the U.S. Climate Resilience Toolkit. But it mostly is providing you information about temperature and precipitation. If you're a fire manager and you really need information about changes in humidity or fuel moisture, this may not be the ideal tool for you. But there are some other things you want to look for in a tool as well, once you've decided that it covers the area and the variables you need. One thing is that you want a tool that is pointing you towards some sort of reputable source for the data. So that might be peer-reviewed literature, links to papers about how data sets were developed, or you're looking for data that's coming from a reputable source, say one of the federal agencies that are typically underlain by peer-reviewed data as well. Because I will tell you, there are some climate tools out there that don't do as good a job putting together information. Another thing I like to look for in a data set is that it's easy to learn about the data. You might want to know what area is a tool averaging over, or what years have they produced that average temperature for. You want to be able to find that easily, and perhaps even quickly and easily find the links to other critical information you might need. Like, how is this data set using the term normal climate? Do they mean the average? Do they mean a median? Right? And so when you start seeing these information buttons pop up linking to the answers to your questions, that's always helpful and a good sign. Another aspect that you want to be able to look at is that it's possible to look at the range of variability for future climate. So this is showing the average change in summer precipitation versus average change in winter precipitation for Boise. Again, this is from the Climate Toolbox. This is RCP 8.5, kind of a high scenario, roughly the middle of this century versus the end of the last century, okay? And if you look at the average across all models, it will tell you that there is basically an increase in winter precipitation and no change in summer precipitation. Looks pretty good. But if you were to look at all of the models, you would see this huge scatter, right? So this big dot's the average, the little dots are individual model projections for that average change in precipitation. And you can see some models that get wetter in both seasons, quite a bit wetter, and some models that get drier in both seasons, or that get drier in one season, but not the other. Right? And there's a big difference between summer precipitation stays the same, winters get wetter, and it gets drier in all seasons. So if you're putting together scenarios, you want this ability to look at range of variability. But something else you're going to run into is the fact that different data are different. So this is showing time series plots of the water year average, maximum on top, minimum on the bottom, temperature over the upper Colorado River Basin from 7 different observed data sets. So these are gridded products made from observations. And they tell you a lot of things that are the same, right? About warm years in the 30s and particularly cool periods in the mid 70s. But the overall answer they give you is different. And this is, it turns out, predictable given the way the data sets were made. And different data sets may be more appropriate in different situations. Happily for you, though, the tool is really only one part of the process. The tool is going to help you know what future climate changes might be like. But a lot more of the planning process is about understanding the climate sensitivities of the species or system you're working in, thinking about what kinds of decisions you're making, what resources are available to you, both for management and for using climate information, and what information you need. And this is really where the climate tools start coming in. Just one of these sort of 4 basic questions. Finally, if you are feeling lost, there are people who specialize in using climate data and these climate tools. Obviously, our next 3 speakers are 3 of those people, but throughout the casks, in many of your agencies, and in from other sources like state climatologists or NOAA's regional climate centers, there are experts there who can help you with specific questions or walk you through a process if you have a particularly challenging application. And they will be happy to talk to you. Okay. So now, Sean, I will pass it back to you to move on to the more interesting, fun tool parts of our presentation today.